Hi, how are you? In this video, I'm going to explain the bisection method and how to implement it on Python, or you can implement it on Matlab or any other program. Eventually, the concept is the same. So we start by importing. We need to import, um, NumPy. And NumPy is just a library which helps in some of the mathematical terms and so on. And we also need to import Matplotlib library. Yeah, I think it's pyplot as plt. And then I will show you the graph of what we are trying to do. I will use a very simple function. So, for example, we'll say x equals mp. And then here we are specifying like an interval. So also you can just copy and paste. Okay. So our function will be just x squared plus 6x plus 5. And we all know the analytical solution for this function, which is very easy. It's just, x plus 5 and x plus 1, right? We'll say this. What we'll do is equals 0, and then we'll say, okay, then that means x equals minus 5 and x equals minus 1, right? So this is our analytical solution. So our solution is minus 5 and minus 1. And now we want to do this numerically, and we are trying to do this with the bisection method. And first, let me grab this. So plt. And let's just do grid, and then let's just do show. So so this is our function, right? And as we see, it intersects the 0 at z equals minus 5 and z equals minus 1. So we need to do this now. I can put this here numerically. And the way to do this is we first need two initial values. All of this I'm putting a description for a very good YouTuber who made like a very good explanation of the bisection method and so on. I'll put it in the description if you want to review. So what we are doing here is, okay, let me plot this. We need to put the initial values, which are, making sure that our 0 is between them. So if now I'm putting a as minus 11 and our b is minus 1.5 or anything here. So we need to also assert that. So assert, we need to make sure that f of a by f of b, it will always be negative, right? So less than 0. And but what is f of a? So we need to define a function which is called f, and we can call it text x, and we can just copy paste this same thing here, right, and return zip. Yeah. Zip. Okay, cool. So now what will happen is this will assert that we get a negative value, right? Or we will make sure that both of our initial guesses are making sure that the zero that we want to get is between them, right? So cool. So then we'll make like a maximum number of iterations, which is, let's say, 20, and we need a tolerance, let's say 1, and you will get this tolerance when I go inside the loop. So so what I will do is a for loop, and this could be anything, right? So any number, let's say I, people of I, for I in range, and this is from maxi, right? Maximum number from 0 to maxi, from 0 to max, right? So this is the number of iterations, and then inside it we'll say tolerance equals apps. This is absolute value of what the tolerance is f of a minus f of b, right? So f of a minus f of b. And then here we're going to get the midpoint, right? So let's say midpoint, or mid equals a plus b over 2. A plus b over 2. Okay, and then there is a very big if statement. So first, if the tolerance is more than, and this is error, or this is this value will be determining when our program stops, right? So we can say, okay, 0.1, and for example, our tolerance, we already know that it's 1, right? So this will just calculate the new tolerance, and this will make sure that, you know, for a tolerance of 1, this will be bigger, right? Bigger than 0.1. So our function will be true. So it will just go inside. So inside we will make a new variable. Let's call it midpoint. And this midpoint will be let's say f of mid, right, by f of b. So what we are doing here is, I've already done this. So, you know, this is our midpoint, right? And first we are multiplying this by f of b. Let's say this is b, right? So if this is b, then this by this will give us a positive value, right? Positive value. So then that means that we have to cancel this b and make our new midpoint is b. Midpoint equals b, right? And we keep a constant. Else, if this by this gave us a negative value, that means actually this b is not here, it's somewhere here, right? Or this is b actually, and then a should change to the midpoint, right? Simply. So what we'll say is if midpoint, so if midpoint is less than 0, or as I explained it, let's say if it's more than 0, then B equals mid. So B will equal mid, right? So we are changing the value of B to the mid. And else, so else, that means that this product gave us a negative value. That means we need to change the value of A, right? So A will be mid. And this will be the else for this if, right? So else solution, and this is a new variable, is mid, right? Or midpoint actually, or mid, yeah. Okay, and then print solution. And let's just say, okay, and we can just put something here and say, okay, this is our solution. Oh, yeah, so I just added break, so it won't, you know, continue to print this one. And if we run it now, this is our graph, and it says the solution to the problem is 4.99. So, but we expect it to be 5, right? So if we really want to reach 5, we should increase this decrease this tolerance. So if you make it like, you know, more accuracy, you know, it will better reach 5, right? So the more we put this, the more we will exactly get 5, but we will get more iterations, or even the iterations, you know, this is out of our range, maximum range. So we need to really increase the iterations, and this will take more computing time and so on. So that's why it's sometimes not logical to get a very exact solution. And just for fun, if we want to find the root for this root, it's going this way, right? So it's going to the -5. But what if we want to go to the -1? If we want to go to the -1, so as we saw, this will vary by our initial guess. So for A, we chose -11. So if we change it to somewhere here, so for example 4, I think we should get the -1. So let's change A to 4 and see. So yeah, so it reached the -1, right? So minus 0.9999, which is -1. And we can, we can just plot it here just for fun. Scatter, and let's say this is A and f of A, and let's also put scatter B and f of B. This way you will always see the graph going near the so we started by 4, and this is minus 2.5, and then B went from 4, and this was our midpoint, which became B, you see, and then this is another iteration, and we see that this also went here, and then this started moving until we found our midpoint, or our point here. So we started going this way, and then we start going this way until we reach our point. So I hope you really enjoyed this video, and I hope you learned how to implement this here in Python, or you can also implement it in Matlab, and you get the general sense of the algorithm. And thank you, and good luck.